All right, so we're going to be looking at enantiometric SS. What is enantiometric SS? Enantiometric SS simply refers to the difference in the quantities of two enantiomers present in a sample. When we have, we talk about stereoisomerism, talk about the optical isomers, where we have the stereomers and enantiomers. Enantiomers are simply mirror images of compounds. So when you have one and then you have the other one that's a mirror image of it, that's enantiomer. So when you have two enantiomers together, the difference in their quantity is going to represent the enantiometric SS. What is it usually? It usually expresses the purity of the chiral substance. It helps to know that it's actually entirely like a pure enantiomer or an enantiomer that has other like and the other second one being attached to it. Where enantiometric SS usually applied in is when you are checking the synthesis. When you are checking synthesis of object to check whether actually the synthesis went in the right direction and gave you the type of enantiomer you're looking for. So a racemic mixture, what's a racemic mixture? A racemic mixture is actually a combination of two enantiomers in equal amount. So you have 50% of this and you have 50% of the other. When you have both of them together, it will be a racemic mixture. In that case, the enantiometric SS is 0%, because I mean, if you have 50% minus 50%, remember is the difference. Remember, it's the difference. If you have 50% minus 50%, that's going to give you 0%. While a single enantiomer has enantiometric SS of 100%, simply means that there's only one enantiomer there and there's no other one. So 100 minus 0 is going to give you 100. So for a given proportion of two enantiomers, the observed specific rotation of the mixture, which is alpha SP means, is going to be calculated as alpha SP means equal to observed rotation divided by path length times concentration. So enantiometric SS is equal to percentage of dextrorotatory isomer minus percentage of level rotatory isomer, and percentage enantiometric SS is equal to the observed specific rotation of the mixture divided by specific rotation of one of the pure enantiomer times 100. And then for the positive enantiomer dextrorotatory isomer, you can get the percentage present using this formula, and for the level rotatory isomer, you can get the percentage present using this particular formula. So let us look at this particular example and try to apply what we have learned about enantiometric SS. The optical rotation of a sample composed of the two enantiomers of 2-butanol was determined as alpha OBS equal to minus 0.45 degrees. Now, minus 0.45 degrees as the observed rotation simply tells you that even if you have the two enantiomers there, the enantiomer that's already outstanding is the one that is negative, that is level rotatory, because the observed rotation you are seeing there is minus 0.45 degrees. If the specific optical rotation of the pure enantiomer, which is the dextrorotatory one, is 13.52 degrees, determine the enantiometric SS and calculate the percentage of the positive and negative isomers, given that the cell path length was 0.6 dm and the concentration of the 2-butanol for the two enantiomers in the sample was 0.15 gram per mil. So let us give solution to this particular question. What is the question we're asking? They're asking for the percentage of the positive and negative isomers. So this is what we're actually going to arrive at. For us to be able to solve this, we need to know the enantiometric SS. And for us to know the enantiometric SS, we actually need to first of all know the specific rotation of the mixture. So for us to get specific rotation of the mixture, we simply do the alpha SP mix. Alpha SP mix is equal to the observed rotation. Observed rotation is minus 0.45 degrees divided by path length. Path length is 0.6 dm. 0.6 dm times concentration, C, concentration, and the concentration they gave to us here is 0.15 gram per mil. So we have 0.15 gram per mil. So we have 0.45 divided by 0.6 and then divided by 0.15, and that's going to give us minus 5.0 degrees. So the observed specific rotation for the mixture is minus 5.0 degrees. The next thing we're not going to calculate is that we're going to calculate the percentage enantiometric SS. So percentage enantiometric SS, percentage enantiometric SS is equal to, in brackets, the specific means and the observed rotation of the mixture, which is minus 5.0 divided by the specific rotation of the pure enantiomer, which in this context, specific rotation is 13.52. So you do divided by 13.52 degrees, and then you now multiply by 100. You multiply by 100. So our answer is going to be 5 minus 5 divided by 13.52, and then you multiply by 100. So our enantiometric SS here is going to be minus 36.98, which is approximately minus 37, minus 37. So that's what we have there. So the enantiometric SS here is minus 37 degrees, if you like. Also, or minus 37%, if you like. What does that minus tell you? It tells you that what is actually in SS is the negative enantiomer, because enantiometric SS is the difference in the quantity of the two enantiomer. So if the negative is actually more, you are now having a minus to depict that. But let us confirm that indeed the negative is actually more. Sorry for the break in transmission, it was due to a technical problem. Now, for the positive isomer, present, we are going to use the formula which I have already written prior to this, and that's 100 plus enantiometric SS. And enantiometric SS here is minus 37. Plus times minus is going to give us minus 100 minus 37 divided by 2 will give us 31.5%. And then for the negative isomer that is present, negative isomer present is equal to 100 minus enantiometric SS. Minus times minus will give us plus. 100 plus 37 divided by 2 will give us 68.5. Now 68.5 minus 31.5 is going to give us 37. And then I told you already that the reason why we have a minus is because you have an excess of the negative isomer. And you can already see from the calculation that you have 68.5% of the negative isomer, which is the level rotatory isomer. And then you have 31.5% of the positive isomer, which is the dextro rotatory isomer. It simply means that in this particular mixture, you have more of the level rotatory as opposed to the dextro rotatory. And because of that, that's why the observed rotation you're having here is minus 0.45. Minus 0.45. And then you now have all of this calculation featuring the minus 5.0 in the specific niche and the enantiometric SS, reflecting that you have more of the negative as opposed to the positive. So with this, we have covered this, and we're going to be progressing into chirality and look at other aspects of optical activity. Let's go.